The Constraint Manager for OrCAD is a spreadsheet-based interface for adding your constraints in the schematic. So as you'll notice, if you look to the left-hand side, it's very similar to the Constraint Manager in PCB Editor. We have an electrical domain for adding your electrical constraints like impedance and length constraints, differential pairs. We have a physical domain for adding your line width, via size, some of the rules for differential pairs. We have a spacing and same net spacing domain for adding your spacing requirements between different elements. So first I'm going to start by adding some constraint sets. So I'm going to go into the Constraint Set Designer, or C-Set Designer, and select a worksheet in the electrical domain, and then click on Create Electrical C-Set. I'm just going to name it Rules, and we're going to start adding some constraints in here. So we're starting with the wiring worksheet, so I'm going to select a topology, min daisy chain. My stub length I'm going to make at 200 mils, that's my maximum stub length, and my maximum exposed length is also 200 mils. That's the maximum length that a net can run on the external layer before it must via down into the top, into one of the internal layers. Next I'm going to add a via rule. I don't want any more than the maximum number of 2 vias on a net. My impedance rule is going to be 60 ohm with a 2 ohm tolerance. My min-max propagation delay, I want to go between longest and shortest pin pair. My minimum is going to be 1000 mils and my max is 3000 mils. Okay, so there I have a rule set. I'm going to add that rule set to one of my buses here. So I'm going to select my rules, and you'll notice that if I add it at the bus level, it is actually inherited by every net or every bit of that bus. So next, I'm going to go ahead and create a match delay or relative propagation delay. So I'm going to go into the relative propagation delay worksheet, and let's contract everything. I'm going to select all the nets in this particular bus. So it's my VD bus, 0 through 7. And I'm going to create a matched group. And I'm just going to call it VD underscore M group. Okay. Now I'm going to add the constraints at the group level. So again, I want my pin pairs to be longest to shortest. This will allow the system to select a pin pair that will be the target length. My scope is going to be global. My delta I'm going to set at 0, and my tolerance is going to be 10 mils. So that means I have a plus or minus 10 mils for my tolerance, which gives me a 20 mil window to meet the tolerance. At this point, I'm going to go ahead and update my printed circuit board with the rules that I've just added. So I'm going to select Update to my update board. It's finished, so let's bring up our board and take a peek. Okay, I'm going to update my design status and make sure that all of my DRCs are up to date. So it looks like I have about 18 DRCs. So we can see some DRC markers on the screen, and it looks like some of them are electrical delay. There's my exposed length. It looks like I have this trace here is too long. Have some impedance issues and some relative propagation delay issues here. So we can actually go and look at the Constraint Manager and see exactly where our problems are. So if we go and look at the wiring worksheet, we can see that on D0 we have an issue with the exposed length. Yep, and we saw that. We actually have one net, it looks like D0 again, that has an extra via. It has 3 vias instead of our maximum of 2. We have there are a few nets here, there are a couple, net D0 and D1 are not meeting the 60 ohm impedance for part of it. And min-max propagation delay looks like our minimum, we're not meeting our minimum delay in a lot of these. Okay, so I'm not actually going to fix these at this point. Let's go ahead and save our design, and we're going to close it down. I'm going to go in here now, and I'm going to actually update my schematic with the board, mainly because I want my default constraints for my spacing and physical rules, and then I also want to bring in my stack up. So I'm going to go and select that design, which is my update design, and I want to merge with the existing constraints in my schematic. So I'm going to click import. It's going to tell me, it gives me a nice report as to what it did. Go ahead and close that window, and you can see now that I have default rules for my physical and spacing requirements. Okay, so now I'm going to go back into my CSET designer and create some more constraint sets. So one of the things I want to do is create a constraint set in my electrical domain for differential pairs. So let's say create electrical CSET, and I'm just going to call this one DP. Let's click OK, and then I'm going to set my gather control to ignore. So I'm going to ignore the length. For uncoupled length, I want to ignore the length from the pins to the gather point, because I know that this portion has to be uncoupled. Then I'm going to make my maximum uncoupled length pretty short. Okay. My static phase controller, the matching in length between the two members of a pair, the overall length is going to be at 25 mils. And then my dynamic phase, which checks at every bend, I want a max length of, or I want my delta. This is basically the delta in tolerance, so max length is 0, and then my tolerance is going to be 20 mils. Okay, next I'm going to go into my physical rules, and I'm going to create a constraint set for my differential pairs again, but in the physical domain. Okay, so I want rules for differential pairs that are going to be, it's going to be a 90 ohm differential impedance. So my line width is going to be 8 mils, except on the 2 internal layers, they're going to be 5 mils. I'm not going to set my maximum line width. My neck width, I'm going to allow it to neck down to 4 mils on every layer. I'm not going to set the maximum length that it can neck down. Now I'm going to set my primary gap. So the primary gap, or ideal gap between the two members of a pair, is going to be 8 mils, except again on my 2 internal layers it's going to be 5. Although my net gap, it can neck down to 4 mil spacing, and then I'm going to give it a tolerance. Plus or minus tolerance is going to be 0.5 mils plus and 0.5 mils. So plus or minus 0.5 mils, which means that my very minimum spacing is going to be my net gap minus my minus tolerance, which will give me a 3.5 mil very minimum gap. Just to check and see what this will look like on the board, I'm going to show the differential pairs in the differential pair viewer. So as we zoom in, I can look at my top layer and see it gets 8 and 8 mil spacing. It shows my very minimum spacing. And then on the internal layers, you get 5 and 5. Okay? And on the bottom is 8 and 8 again. So now we can actually, and if it has to neck down, it's going to be 4 and 4. So now you can see what it's actually going to look like on the board. So now that we've created these, I'm going to exit here, and first we need to go ahead and define our differential pairs. So we're going to use auto setup of differential pairs. I have my DP underscore is going to be the prefix for the name of the pairs, and then I wanted to search for nets that have an underscore P and an underscore N, and that will show me my my possible differential pairs. If that's what I want, I can go ahead and click create. Otherwise, I can remove any of these that might be a problem, but it actually looks just fine, so I'm going to create them and exit out of this form. So now I have all my differential pairs. Let's go to the differential pair worksheet in the electrical domain, and here's all of my differential pairs. I have 8 sets of differential pairs. I'm going to select them all and give them the differential pair or DP rules for my electrical constraints. Next, we'll go to the physical domain, and we'll do the same thing. We're going to give it our DP 90 ohm differential pair rule. Okay, next, we need to work a little bit in the spacing area. So we're going to go to the spacing worksheet, and we see that we have some net classes here. We have a couple of net classes. I actually need to create one more net class. I'm going to create a net class that includes my the signals in my VD bus. So now, by the way, that since we have imported from our board, we actually have our X nets that show up. So this bus isn't just VD 0 through 7. Each one of these is actually an X net that includes an unnamed net. So I'm going to go ahead and create all of these, or select all of those, and I'm going to say create class, and I don't need to create this in the physical domain. So I'm just going to call this VD nets. Okay, now I have all of my net classes at the top. I have clock nets, DC nets, and VD nets. So I need to create some more constraint sets. So let's go to the spacing domain and create new spacing C-set. You can see that we have our default spacing constraints that were brought in when I imported the board data. So I'm going to create 3 different rules. We're going to have an 8 mil rule, and let's just go ahead and select this whole thing. So everything sets to 8 mil. Now I'm going to create a 10 mil. Again, we'll select all the way across. Fill it in at 10 mils. And one more. We'll create a 12 mil spacing constraint. Okay, so here's our 12 mil. Okay, perfect. So since we've created those, I'm going to exit. Now we're actually going to leave everything really set at 5 mils. Okay, so everything's going to get a 5 mil constraint set as far as spacing goes. But I'm actually going to go in and create some special class-to-class rules. So I'm going to say create class to class, and then I want to create a class to class rule between my clock nets and my DC nets. Then between my clock nets and my VD nets, then between DC nets and VD nets. Okay, so those are my 3 class to class rules. I'm going to click OK. And now I'm going to go ahead and set the constraint set. So between my clock nets and my DC nets, I want to have 8 mil spacing. Between my clock nets and VD nets, I want to have 10 mil. And between my DC nets and my VD nets, I want to have 12 mil. Okay. So this is actually all of the constraints I need to set in this particular design. So I'm going to go in at this point and I'm going to exit the constraint manager and I'm going to save my design. Okay, I want to make sure everything is saved. So all of these constraints are actually saved within the .dsn file. Okay, so I saved the constraints. I'm going to relaunch the constraint manager. And I'm going to update my board file again. So I want my update board, and let's go ahead and import my new constraints into my board file. It's finished. Let's bring up the board. And here, let's zoom around the whole thing. Let's go into display status and update our DRCs. And now it looks like we have 20 DRCs. So we can see a couple extra DRCs right here. So we know that we have these DRCs. It says that it needs a 12 mil constraint. So, and that's because this is a DC net and this is a VD net, and we just set our class to class. So now if we go ahead and shove those traces, we can clean those up. Also, we've set constraints for all of our differential pairs. So if we go into the constraint manager, we can look at our differential pairs. Let's look here. And we can see that actually none of them are routed. So we see yellow here because nothing is routed. Okay. So let's go ahead and minimize that for now. And I'm going to go ahead and route one of my differential pairs. And you'll see by adding the rule sets, we can, I'm going to change the pattern here to vertical. By setting the constraints, the nets automatically route to the required line width and gap. Okay, so you'll notice that on the external layer we actually have an 8 mil line here, and then we have 5 mil line here, and our gap is also 8 and then 5. So that's it for this design. I want to show you one other thing. So we have a new feature in the constraint for OrCAD, constraint manager for OrCAD. I'm going to go ahead and exit the constraint manager here. I'm going to close this design and open up a different design. So I have a design schematic. It's DDR. Okay. So this schematic has some DDR nets, okay, and buses, DDR buses really. So I'm going to bring up the constraint manager, and you can see that there's really no constraint set or anything. We have our differential pairs defined, but that's about it. All of our buses and nets are just, there's no constraints present. So what I'm going to do is go to Design and DDR Bus Designer. So our new DDR Bus Designer allows the engineer to very easily define groups of rules, or have the system define groups of rules based on the single interface that they fill out. So you have the DDR high-speed bus designer, and I'm going to, so this is the name, this is going to be the prefix for all of our byte lanes. So, and what we're gonna filter our nets pretty much by that same okay. So we want DDR3 M0 DQ. So all nets that start with that. Okay, so this is actually a 32-bit bus, and it includes the strobe signals or differential pairs. So first I'm going to tell it how many byte lanes are going to be included in this bus. And we have 4 byte lanes. Okay, so it automatically named our byte lanes, and we have a 0, 1, 2, and 3. And now we're going to choose the nets that belong in that byte lane. So okay, I'm going to assign these nets to the selected bus. Now I'm going to go down and select the next byte lane and select the next group of nets. Okay, and assign those to the next selected byte lane. Select the next byte lane. Assign those, and then the last one can just assign that. Now last I need to go ahead and assign the strobes. Okay, so the first set is assigned to the first byte lane, the next one to the next byte lane, okay, and so forth. Okay, so once they're all assigned, and we can look and make sure that everything was assigned properly here. Now we can set up some of our basic rules. So, what is the spacing that I want within the byte lane? So between the different signals that are included in the byte lane. Okay, so I want 6 mil spacing there. From byte lane to other byte lanes, I want 12 mil spacing, and then from byte lanes to the rest of the board, again, I want 12 mil spacing. Okay. I'm going to select some special net scheduling. So I want source load daisy chain, and actually I can select multiples and have it fill all of them in at the same time. My layers, I'm actually going to select the layer that I want these to be routed on. So that byte lane is going to be routed on layer 3, and so I'm just selecting a layer and saying apply constraints. I could select multiple layers too. My next byte lane I want on layer 5. The next one, layer 3, and the last one again on layer 5. I'm not going to select a via. Well, I could select a via, I guess, at this point. So I'm going to go ahead and select the via. I want via 2 and apply constraint. Okay. Next, I'm going to, I don't really need to select a line width. What I'm going to do instead is set an impedance. So for these, I want a 50 ohm impedance, and I'm going to set a 10% tolerance. Next, for propagation delay, I want longest to shortest pin pair. And then I'm not going to set a minimum, okay, but I will set a maximum propagation delay. So we know that we don't want these any longer than 1 nanosecond. Okay, so that is the maximum propagation delay. And then as a relative propagation delay, again, I want my pin pairs to be longest to shortest. The delta is going to be 0, and then it's going to be, the tolerance will be plus or minus 10 mils. So, and that's all you really have to do. You just fill in these various little forms and then click Run DDR Setup. What Run DDR Setup is going to do for us, it's not only going to set up our spacing constraints, but it will actually create our net classes for the different byte lanes. It will create our class-to-class spacing and it'll assign our basic spacing, but also class-to-class spacing. It will set propagation delay. It will create match groups and set the relative propagation delay. Okay. It will set impedance rules. Okay, so that is finished, and we'll say done. And let's go in and look at some of our constraints. So here we have a whole bunch of net classes, and each one of them has their rules. So we're in the wiring worksheet. So we've set topology, we've set the layers that they must be routed on. Let's see, impedance, we've set the impedance, we've set the min-max propagation delay, or at least the max propagation delay. We've set the relative propagation delay in the match groups. And in our physical rules, we haven't really set the line width, but we have set our class-to-class spacing. So here's all of our class-to-class spacing. Okay, so, and that is, that's how the DDR bus designer works. And that concludes the end of our demo.